Okay, let's get back to language. Again, we are working toward being able to communicate with each other around organic chemistry, and that includes words and drawings. And one of the most important sets of words that we have are those that describe functional groups. A functional group is loosely kind of an interesting part of a molecule. Right? So a part of a molecule that gives it its biological activity, that gives it its reactivity, that gives it its smell, feel, all the kind of properties that a molecule has are due to its functional groups. And so what I want to do, instead of spending a lot of time on this in one chunk and telling you the broad names of things and how to name specific molecules, I'm going to lay out what these words mean in general. And so to start off this class, I want to build these words in very quickly. So you'll be able to look at a molecule and say, oh, that's an alkyne, or that's an ester. Later on, we'll get into how to name a specific molecule. That's also very important for lots of reasons, not the least of which is to be able to tell if two molecules are the same or different. But let's put some of those conversations off, and now I want to just get through what these classes of molecules look like, and I want you to be able to tell me, given a molecule, what it is. It is an alkyne, it is an alkyl halide, so forth. Okay? So let's dive in. Alkanes. Alkanes are essentially the absence of a functional group. So only CH sigma bonds, right? So something like pentane, there's no double bonds, there's no pi bonds, there's no other atoms, only CH, alkane. All right? Alkene are things with a pi bond. One pi bond, so what we might call a double bond. Alkynes, right? The Y is Y-N-E, yne. Alkynes contain triple bonds. So these are two pi bonds orthogonal to each other, right? So again, I don't want to get too much into the details here, but you've got one pi bond that looks like this, and then the other one is orthogonal to it. And there's another bond like that. So this is when we draw this is shorthand for that. One more, alkanes, alkenes, alkynes, and one thing I'll throw in that's sort of a special case is an arene. Arenes are compounds that have a 6-membered ring with 3 alternating pi bonds. You'll see this come up again and again in biochemistry, in medicinal chemistry. Just about every drug you can name has some arene unit in it somewhere. The parent molecule, I guess I can name, is called benzene. But the general case of compounds that are benzene-like we call arenes. Sometimes we will lump alkanes, alkenes, alkynes, and arenes into just hydrocarbons. Hydrocarbons are just what they sound like. They contain hydrogen and carbon, and that's it. All right, so if it only has that, we'll talk about hydrocarbons. Most fossil fuels, gasoline, these are hydrocarbons, only C and H. So we will put haloalkanes, which are also called alkyl halides, and nitroalkanes in this spot because they're still, at least in nomenclature terms, kind of considered more or less hydrocarbons, right? They act more or less like it was just C and H. Alkyl halides are simply, reminder, a halogen. Halogens are that second to last row in the periodic table, right? F, Cl, Br, I, the one below it that's made up. So these are halogens. And we talked about fluorine and its electronegativity. All of these all of these atoms are at least somewhat electronegative. So hydrocarbons that contain a halogen, something like that, this would be considered an alkyl halide or a haloalkane. Both of those classes are fine. A nitroalkane contains, yes, it contains a nitrogen, but specifically it contains a nitro group. Now, this is something that students usually get wrong, and so I want to emphasize it right now. A nitro is an NO2. That is a nitro group. A nitro group has a nitrogen with essentially 2 bonds to one oxygen and 1 bond to another. It's also got a positive charge on the nitrogen and a negative charge on one of the oxygens. Here we're going to mostly focus on nitrogen, oxygen, and sulfur containing compounds with still a single bond. So a really important one is the alcohol group. Alcohols have an OH, which is to say an oxygen bound to a carbon and then bound to a hydrogen, right? This is an alcohol. Again, we're always going to draw out the hydrogen in an alcohol. The only hydrogens that we don't draw are CHs, okay? Now, if an oxygen has 2 bonds to a carbon, this is an ether. Okay, so here you might ask, why did I draw out the CH3? I thought we weren't going to draw C's and H's here. Well, I didn't need to. I could have just drawn the little stump and called that a bond. But I also think it's a little bit easier to read if I draw it out. And so here, these communication rules are a little bit soft. And what I'm going to do is whatever helps me communicate the clearest. Okay? So, but to the matter at hand, an ether has an oxygen that has bonds to carbons on either side. So amines are compounds with nitrogen in them. And here, we're actually going to use the word amine regardless of how many hydrogens are on the nitrogen. So whether I have an NH2, an NH, or an N with no H's, I'm going to call all of those amines, right? If I have an NH3, I'll just call that ammonia, because that's what it is. Right? You'll notice that I didn't talk about what is it if I have an O with just 2 H's. Right? The technical term for that is water, so let's use that. Okay. So again, alcohols are compounds with an OH bond. Ethers are compounds with an O between 2 carbons. The intermolecular forces between these are going to be very different. In amines, some amines are going to have an NH, some amines will not have an NH. And again, the intermolecular forces between now things that we call both amines, they're going to be very different. Okay, so we can't just name something and know that much about it. We do need to look at the structure. I put thiols up here too. You'll notice that thiol and alcohol rhyme. That's because a thiol is the sulfur equivalent of an alcohol. All right, so if I see an SH, I'm going to call it a thiol. Sometimes these are also called mercaptans in the very old literature that you're probably not reading. But if you hear about ethyl mercaptan adding to natural gas, ethyl mercaptan is ethane thiol. Okay, so alcohols, ethers, amines, thiols, compounds with single bonds, including nitrogen, oxygen, and sulfur.